Hello, hello. Here is the video going over the Chapter 6 Solving Trig Equations test review. As you watch this video, you will notice that I do not do every single problem just because a lot of the problems start to get a little bit repetitive. And so just doing a couple from each topic should be enough to help you get prepared for this particular test. So for number 1, we're solving trig equations using the unit circle. So it says solve for x where x is in between and inclusive of 0 and 2 pi. Leave your answers in exact form. So the very first thing I want to do is I want to isolate this trig function, meaning I need to get rid of the root 3 and the 2. So I'm going to start by subtracting root 3 from both sides. So I have 2 cosine of x equals negative root 3, and then I'm going to divide both sides by 2. So I have cosine of x equals negative root 3 over 2. From here, I'm going to go to my unit circle. As you can see, I have the small unit circle in the middle of the screen, and I'm going to use that to help me find my answers. Cosine is my x-coordinate around that unit circle. So I am looking for when my x-coordinate is a negative root 3 over 2. And that's right here and right here. So my answer for this question will be those corresponding angle measurements. So I'm going to write x equals 5 pi over 6 and 7 pi over 6. And that is your answer for number 1. Number 2 is a similar idea, so I'm going to go ahead and isolate my tangent of x. So from here, I'm going to divide both sides by 3 to get tangent of x by itself. So I have tangent of x equals negative root 3 over 3. Now, if you look at your unit circle, we don't see our tangent values right on the unit circle. If you recall, tangent is y divided by x. So what I can do is I can take these y coordinates and divide them by your x coordinates. I'm not necessarily going to go through all the details of where these answers come from, but if I were to take 1/2 divided by root 3 over 2, that's going to give me 1 over root 3, which becomes root 3 over 3. So tangent of pi over 6 would give me root 3 over 3. For pi over 4, if I take root 2 over 2 divided by root 2 over 2, that gives me 1. And then if I take my y-coordinate divided by my x-coordinate for pi over 3, that's going to give me square root of 3 for my tangent. What I'm looking for is I'm looking for negative root 3 over 3. So the beautiful thing about the unit circle is that it is symmetrical. So this right here is a positive root 3 over 3. If I go straight across in this quadrant and I divide my y by my x over here, this would give me a negative root 3 over 3, which is actually what I'm looking for. If I go straight down, this is a negative divided by a negative, so this would give me a positive root 3 over 3. And then if I go straight across, I have negative 1/2 divided by root 3 over 2. That would give me a negative root 3 over 3. So the angle measurements that I'm looking for this particular question is the corresponding angle measurements where you get negative root 3 over 3. And that was 5 pi over 6 and 11 pi over 6. So I'm going to write x equals 5 pi over 6 and 11 pi over 6. All right, continuing on, I'm going to go ahead and erase some of the stuff that I put on my unit circle. I'm going to keep the tangent values there because they might be useful in the future, but we'll see. The next one, I'm going to add 1 to both sides. Again, isolating my trig function of cosecant. So that gives me 3 cosecant of x equals 6. Divide by 3, and I get cosecant of x equals 2. Now, cosecant is one of our reciprocal functions. So instead of finding cosecant, I am actually going to find sine. And if I take the reciprocal of 2, I'm really looking at 1/2. So sine corresponds to my y-coordinates. My y-coordinate equals a positive 1/2 right here and right here. So my corresponding angle measurements are pi over 6 and 5 pi over 6. So I have x equals pi over 6 and 5 pi over 6. All right. Last question on this particular slide. I'll erase this one too. Okay. Isolating my trig function. This one I am isolating cotangent. So I am going to start by subtracting 3 from both sides. This says equals 2, by the way. Kind of got covered by my blue circle. Continuing, that gives me cotangent of x equals -1. Now, if cotangent equals -1, that means tangent also equals -1 if you wanted to flip it over. So what I'm looking for is I'm looking for the tangent values that equal -1. I can see my tangent right here is a +1. So once again, I'm looking for those negative values of tangent. If I go straight across, I have negative divide or positive divide by negative, so that would give me a -1 over here. I go straight down, negative divide by negative is going to give me +1 over here. Straight across again, that's -√2 over 2 divided by √2 over 2 is -1. So the two angle measurements that I'm looking for that give me a -1 for tangent are 3 pi over 4 and 7 pi over 4. So I have x equals 3 pi over 4 and 7 pi over 4. So for these particular questions, it's super important that you do have this unit circle memorized. Like I said, we are using this unit circle to be able to find all of these values, so it becomes a little tricky to do if you don't have that unit circle memorized. Essentially, just remember cosine is your x, sine is your y, tangent is y divided by your x, and then from there you're just finding those corresponding coordinates and then those angles for those particular coordinates, and your answers will be those angle measurements. All right, on to topic 2. So topic 2 is a similar idea. It's just that you are not using exact values from that unit circle. So I want to find all values of x, round our solutions to 3 decimal places. So I want to find all of the angle measurements in which sine of those angles gives me a 0.298. So I'm going to go ahead and start by drawing a picture to help me figure out where these angle measurements are going to be. So I'm just drawing a blank unit circle. Hopefully your circle doesn't look as wonky as mine does. But I need sine to be positive. So if you'll notice, this value right here is positive. Sine is my y coordinate. My y coordinates are positive over here in this quadrant and over here in that quadrant. So I'm just going to go ahead and draw my 2 angles. From here, I'm going to use my calculator. So I'm going to go ahead and find the inverse sine of 0.298. Make sure your calculator is in radian mode since we're talking about radians for this particular problem. And once you plug that into the calculator, that gives me 0.303 since we want to round to 3 decimal places. Now, what does that 0.303 mean? That is actually the measure of this angle right here that I highlighted in blue, which is one of the angles that you're trying to find. So lucky for us, we have one of our solutions, 0.303, and since it does ask for all solutions, I'm going to go ahead and add a 2 pi n to this particular angle, and then that gives me all solutions for that angle measurement. Now there is a second angle, that is this one that I'm looking at in pink. And in order to find that measure, we do need to pay attention to symmetry around our unit circle. So if this wedge is 0.303, that means this wedge over here is also 0.303. And when I say wedge, I mean these angle measurements. So if I look at what I'm trying to solve for the pink, this pink angle measurement doesn't quite go all. My recording just paused for some reason, so I don't know exactly where I stopped talking. But this pink angle doesn't quite go all the way to pi. Like my angle of pi is right here. And it doesn't quite go all the way around to pi. Essentially, it is this piece less than pi. So what I'm going to do to find my pink angle measurement, I'm going to take pi minus my wedge, which is 0.303, and that to 3 decimal places is 2.839. And of course, since we want all solutions, it would be 2.839 plus 2 pi n for our second solution. All right, next one, again, I'm going to start by drawing my circle. All right, still looks a little weird, but that's okay. Cosine is my x-coordinate, and my x-coordinate is negative in this quadrant and this quadrant. So the angles that I'm trying to find are these two angles over here. Again, I'm going to go ahead and use the inverse trig function to solve for my first angle. So I'm going to take inverse cosine of negative 0.418. And when I plug that into my calculator to 3 decimal places is 2.002. Now that 2.002 actually represents this first angle. So our first angle is the one that's given to us from the calculator. So it's 2.002 plus 2 pi n. Now the other angle measurement that I want to find, which again I'm going to highlight in pink, is that piece. Now what I know based off of symmetry is this angle measurement, I'm going to start coloring, is 2.002, which also makes this angle measurement due to symmetry 2.002 as well. So what I can do to figure out the pink, I'm going to go ahead and get rid of those drawings, to figure out the pink is going to be to take 2 pi minus this piece right here, which is the 2.002. So that leaves me with 4.281. But of course, since we want all solutions, we're going to go ahead and take that and add 2 pi n to it. So my tip for these particular questions, it's super, super important that you actually sketch out the angle. So create a blank unit circle. From there, figure out which quadrants your angles are going to be in based off of whether you have sine or cosine. So cosine's your x, sine is your y. And then from there, sketch out your angles. Use a bit of logic with symmetry to be able to figure out both angle measurements. All right, topic 3, the word problems. So Cooper Toy Company has designed a new toy that uses a spring and follows a sine or cosine curve after you wind it up and start it. At 5 seconds, the toy is at its highest point, 18 centimeters above the ground. 4 seconds later, the toy is at its lowest point, which is 6 centimeters above the ground. So I'm going to go ahead and label my highest point. Where did my pen go? There we go. So this is my highest point of 18 centimeters. This is my lowest point of 6 centimeters. What else do I know? At 5 seconds, I'm going to go ahead and label this as 5 seconds. It is at its highest point, so up here. And then 4 seconds later, so 4 seconds later would be 9 seconds. 4 seconds later, it is at its lowest point, so at 6 centimeters. And instead of continuing to go to my right, I'm actually going to go to my left because that's going to help me as I solve my equation later on. So if I go 4 seconds later and that's 9 seconds, I'm going to go 4 seconds before, and that's 1 second. And my graph is also at its lowest point. So here is the graph that I'm going to use to be able to answer this question. Now, in order to write the equation, there's a couple pieces that I need to know. I need to know where my midline is. So my midline is going to be right in between 6 and 18. So if you want to be able to figure that out, you can add 6 and 18 together and divide it by 2. That's taking the average of those two numbers. But that's going to put us at 12. So my midline is at 12. There's two pieces of information that you need to be able to write the equation. Actually, there's three pieces of information. But A is your amplitude, so that's how high or how low your graph goes from your midline. So 12 to 18 or 12 to 6, this distance or this distance, is going to represent your amplitude, which in this case is 6. B is going to tell us, that's what we're going to multiply our x by inside our trig function. So to find b, that's going to be 2 pi divided by the period. And the period is the length of one cycle. So if I look at the length of one cycle, that's going from 1 to 9. So that is 8 seconds, which I can reduce to pi over 4. The other piece of information we need to know is our phase shift. Our phase shift is 1. So when I write my equation, I'm going to write y equals, it is a negative cosine graph because normally cosine would start at your peak. In this case, it's starting at your low. So I'm going to do negative 6 cosine, and then my b was pi over 4. And then x minus your horizontal shift. So it'll be x minus 1. And then my midline is 12, so that would be plus 12. So there's your equation for part A. Now it's super important that your equation for part A is correct because you're using your equation from part A to answer part B. So for part B, I want to find the first and the second time the spring will be at 15 centimeters above the ground. So 15 centimeters is about right here. So I want to find this time and this time. So I want to see where my graph hits at 15. So I'm going to go ahead and set this equation equal to 15. And then you're going to use your awesome equation solving skills to be able to solve for x. So we'll start by subtracting 12 from both sides. That gives me 3 equals negative 6 cosine pi over 4 times x minus 1. Divide by negative 6. That gives me negative 1/2 equals cosine pi over 4 x minus 1. And then from here, you're kind of stuck. There's nothing else that you can really do until you take the inverse of your trig function. So I'm going to go ahead and do an inverse cosine. And what this does is it releases everything that's inside your cosine to be able to solve further. So then I have my pi over 4 times x minus 1 outside of my trig function. I can divide both sides by pi over 4. And then now you take this expression and plug it into the calculator. This question doesn't really specify how to round, so I'm going to go ahead and round to 2 decimal places. So when I put that into the calculator, that gives me 2.67 equals x minus 1. So that means x equals 3.67. Now, the 3.67 is actually your first time right here. So we have our first time. We also need to find our second time. Now, in order to do that, we do need to recognize that this curve is symmetrical. So what I can do is I can figure out this distance. And once I know this distance, I can figure out this distance, which is going to help me figure out my second time. So let's go ahead and figure out that distance between 5 and the 3.67. So 5 minus 3.67 is 1.33. So that makes this distance 1.33, which also makes this distance 1.33. So if I want to find the second time, I could take 5 plus 1.33, which is 6.33. And now we have our second time that this toy is 15 centimeters above the ground. Is it a toy? Yep, a toy that uses a spring. So, putting my answer together, the first time is at 3.67 seconds, and the second time is at 6.33 seconds. All right, that is topic number 3. Moving on to topic number 4, solving complex trig equations. This is when we are going to have to incorporate some factoring. So one thing that I notice is I do have trig functions in the mix, and when I see trig functions with factoring, sometimes my head gets a little overwhelmed. So what we do in this particular case is we do something called u substitution. So what I'm going to do is I'm going to let lowercase u equal cosine of x. And you could really use any variable you want. Doesn't necessarily have to be a u. But I'm going to replace my cosines with a u. That way, I turn something intimidating into something more simple. Because when I see 2u squared plus 3u plus 1, I notice that that is a quadratic that I can factor. And it looks less scary with u's instead of cosines. So I'm going to go back into my brain, use my factoring skills. So I'm going to start by multiplying 2 and 1. That gives me 2. I want to find two numbers that multiply to 2 and add to 3, and that's going to help me set up the box for the factoring. So my 2u squared goes in the first box, 1 goes in the second box. The two numbers that multiply to 2 and add to 3 are 2 and 1. So I'm going to write 2u and 1u. To factor using the box method, I'm looking at each column in each row and looking at the GCF. I'm going to go ahead and start with this row. Those two have a 2u in common. So I'm going to go ahead and put 2u. And then this row has a 1 in common. So I'm going to do plus 1. This column has a u in common. And this column just has a 1 in common. So plus 1 again. So my two factors are 2u plus 1 and u plus 1 equals 0. But of course, we're not actually solving for u. We are solving for angle measurements for cosine. So now I'm going to go ahead and put my cosine back in there. So I have 2 cosine of x plus 1 equals 0. And cosine of x plus 1 equals 0. For this first equation, I can subtract 1 from both sides and divide by 2. So I get cosine of x equals negative 1/2. For my second equation, I can subtract 1 from both sides, so I get cosine of x equals negative 1. And now I go back and look at my unit circle. So cosine's my x-coordinate. I want to find when my x-coordinates are negative 1/2, and a negative 1. So negative 1/2, I see negative 1/2 right here. Whoops. What is happening? Negative 1/2 right here, negative 1/2 right here, negative 1 right here, and I think that's it. So for this one, my two angle measurements are 2 pi over 3, 4 pi over 3, and then for my negative 1, it was pi. So I have 3 solutions right here. And voila! The key with this one is factoring. Once you set up your factoring, set your factors equal to 0, and then you're solving for the angle measurements just like you did for topic 1 at the front side of your review. All right, topic 5. Topic 5 I like to call my trig puzzles. So what we're trying to do is we are trying to simplify or verify, depending on the directions, each one of these expressions. So if I look at number 14, I see cosecant, secant, and tangent. I'm going to go ahead and switch everything in terms of sines and cosines. That way I can see what I'm really dealing with. So cosecant is 1 over sine times secant, which is 1 over cosine, minus tangent, which is sine over cosine. Now, here is what you cannot do. You cannot cancel out these signs because these two fractions are being subtracted from each other, so you cannot cancel them out. Instead, you need a common denominator. So if I look at this denominator over here, it has both a sine and a cosine. This denominator only has a cosine. So what I'm going to do is I'm going to multiply this fraction by sine of x. So for this fraction over here, my numerator is 1 minus this, sine times sine is sine squared, all over my common denominator, which was sine of x, cosine of x. And then from here, I do need to simplify further. So one thing that I notice is I have 1 and a sine squared. If I look at my Pythagorean identities at the top, I can see that sine squared plus cosine squared equals 1. What I can do with this is I can rearrange this particular equation. So since I want to have 1 minus sine squared, didn't mean to highlight, I can take this and move it to the other side by subtracting. So when I subtract sine squared from both sides, that leaves me with cosine squared of x equals 1 minus sine squared. So really, this numerator right here is equal to cosine squared of x. So now I have cosine squared of x over sine of x, cosine of x. Now, cosine squared, I can go ahead and separate. So cosine squared is cosine times cosine over sine times cosine. Now I can cancel these out because it is one fraction. Same thing on top, same thing on the bottom. And then cosine divided by sine is cotangent. So your simplification for number 14 should reduce to a cotangent. All right, number 15. So 15, I notice that I have 1 minus sine squared again, which we already established as cosine squared. So I can go ahead and replace this with cosine squared of x. And secant squared, I can change to 1 over cosine squared. So since secant is 1 over cosine, secant squared is 1 over cosine squared. This is the same thing as cosine squared over 1. And since I'm multiplying, I can cancel these out, leaving me with 1 as my final answer for number 15. All right. Verifying is my favorite because verifying tells me what my answer is. My answer for number 16 is sine of x. Answer for number 17 is sine squared of x. So that's my goal. My goal is to reduce my left side to equal what I have on the right side. If I look at 16 on the left-hand side, I'm going to go ahead and change this to sines and cosines. So cosecant is 1 over sine minus cosine. Cotangent is cosine over sine. Now, I can go ahead and extend this fraction bar all the way across because you are multiplying. Lucky for us, our denominators are already the same, so I don't have to worry about getting a common denominator. So I have 1 minus cosine squared of x over sine of x. Now, I notice I have 1 minus cosine squared up here. And up here, I have my cosine squared and my 1, so I'm going to rearrange it again. So what I can do is I can take my cosine squared, move it to the other side by subtracting. So really, I have sine squared equals 1 minus cosine squared of x. So I can replace my numerator with sine squared of x over sine of x. And once again, sometimes it's easier to recognize what you can cancel out if I expand my square. So sine squared is sine times sine over sine, so many signs. And then those two are going to cancel out, leaving me with, I don't know why it's not writing. There we go. Leaving me with sine of x, which is exactly what we were trying to look for. All right, last one. So last one, I notice that I'm subtracting in my numerator and then I'm dividing. I'm going to go ahead and just focus on the numerator first. I'm going to do it in blue. So cosecant is 1 over cosine minus cosine of x is cosine over 1. I do need a common denominator, so I'm going to multiply this by cosine, cosine over cosine. So that leaves me with 1 minus cosine squared of x over cosine of x. And we've already established that 1 minus cosine squared is equal to sine squared over cosine of x. Okay, so now I'm going to bring it together. So I have my numerator, which is this. So I have sine squared of x over cosine. And I am dividing by secant. Secant I can replace with 1 over cosine. So I have sine squared of x over cosine divided by 1 over cosine. And I know since we're dividing fractions, I can take this and flip it over and multiply by the reciprocal. So I have sine squared of x over cosine times cosine over 1. And since I am multiplying, these two cosines cancel out, leaving me with sine squared of x, which is exactly what we were looking for. All right, so that concludes your video for the Chapter 6 test. Good luck on your test.